A couple of additional examples real quick from section 1.2. I'm going to start with the rational equation you see on your screen. The least common denominator is 3 times the quantity x minus 2. So that's what we're going to multiply both sides of this equation by. And I'm going to go ahead and distribute that and write it as two separate terms on the right side. So we're looking then at 3 times x minus 2 times x over x minus 2. 3 times x minus 2 times 2 over x minus 2. And 3 times x minus 2 times 2 over 3. Then reducing it, each fraction, x minus 2's cancel, x minus 2's cancel, and the 3's cancel, leaving us with 3x equals 3 times 2 minus x minus 2 times 2. No more denominators. So continuing to simplify, let's see, I'm going to think of that as negative 2 times x, and negative 2 times negative 2 would be 4. Combining like terms, 10 minus 2x, add 2x to both sides gives me 5x equals 10, and then of course dividing by 5 gives us x equal 2. Now, you need to look at that solution that we've gotten to our equation and make sure that it's okay to allow x to be equal to 2. If you go back and you look at the original problem, x equal 2 is going to make those two denominators 0, and that's not okay. So what we've got here is a solution x equal 2, which is a solution to the equation that we had when we cleared the fractions. It is not actually a solution to the original equation. So there is no solution to this problem. Now if you start a problem like this by looking at it and making note to yourself that x is not allowed to be equal to 2, then it's really easy to realize at the end that your answer you get isn't going to actually work. I always forget to do that, and I just jump in and start working it. So I have sort of had to train myself to say, all right, I got x equal 2. What happens if I go back and I plug that in? If you think about checking your answer, if you put in 2 into the original problem, everywhere there's an x, you see very quickly that that's not going to work. You're going to get zeros in the denominator and get no solution for your final answer. Now, one other example, let's take a look at this problem. We have 7x over x equal to 7. Again, there's a couple of ways you could start this problem. You could see that x and x will cancel, and we get 7 equals 7, which is true no matter what value of x you have. Another way of looking at that problem is you could think, okay, I need to multiply both sides by x to clear the fraction. That would give me 7x equals 7x, which again is a true statement no matter what value of x you have. This is an example of, and the word left me. Hang on. Oh yeah, this is an example where your solution is any real number, because any value for x you plug into that equation, or any value of x you think about plugging into that equation, is going to make a true statement. So the solution is the set of all real numbers there.